Your CEOs can pick these up from us. Each company will get 12 printed copies of the RFP. Again, Rohan will have access to those. Just get it for your company. I think if the CEO or the president, do all of you have your president selected already? All right, so the 5 presidents will meet up with Rohan after this session is over and get your printed copies of the RFP, your extension cord, and your rim of paper. All right?
Thank you. Okay, before we start the technical sessions, and we're going to look at the RFP as well, as long as I can get through the tech sessions quickly. I'd like to take a moment and remember the crew of STS 107. They perished today 21 years ago. And I was working the mission and in a building where I actually could see out the window and saw the shuttle break up at 8 o'clock in the morning. So me and a few other people actually watched these people die. So this is a fairly significant event in my career. It led to a number of advancements that I was able to make in my career. So I want to take a minute and just remember this crew and their gallant effort to save themselves when their vehicle broke up. In remembrance, if any of you companies would like to put a remembrance of some type in your proposal for the STS 107, because today is their 21st anniversary of the accident, it won't be graded, but it will be very appreciated. So don't do what happened to this crew. This crew was failed by management. It was failed by planning. It was failed by not understanding the risks that was obvious to the program at the time. So there's a lot of reasons that this should not have happened, and they all came out in the report after the accident. So we're trying not to do those. And if you have time, go read that report. It's out there. It's a Columbia Incident Action Board report, CABE. It's online. And I was there kind of front and center. So anyway, enough of that. I got to find slideshow. Okay. You know where slideshow is on PDF here? Okay. All right. This is a combined technical session, so I'm trying to go through it quickly. Okay, this is applicable to all your departments. How do you work in your department? Okay, together you got to decide what needs to be done. So what I usually had my students do when I was CEOs was have them go look at the RFP and pull out key requirements and key decisions, and that became a roadmap for what the company should be doing. So again, you got requirements for your department, you got requirements across departments, things you must design yourselves, what things you must design with other departments, what artwork, what graphics are needed. So take the time to plan that stuff out. Same sort of thing from other departments. So if you think you need something from other departments, and a good example is structures needs area requirements from human and from operations and from automation to be able to plan and produce enough floor space to have all that happen. Plan the work and work the plan. This is an old adage that's been done in industry for many years. So put down on a piece of paper who's going to do what and by when, and then follow it. This includes the decisions on what tasks. Make sure everybody's got an assignment, or 2 or 3 or 4. I usually have more than that. Agree on what major parts of the settlement need to be agreed upon. So you got to have integration with the different departments to know that your combined configuration, which must be settled early, is sufficient to accommodate all the other departments. Communicate. We saw some of this yesterday. Your designs affect other people. Sometimes you communicate a design to another department, then you change your mind and you forget to go back and tell them that you changed your mind. So don't do that. You can schedule meetings, and as Anita used to say, Microsoft Office does them in time periods of a half an hour, but you don't have to have a half an hour meeting. You can have a 5-minute meeting, you can have a 10-minute meeting. The key things are the meeting needs to have the attendance of the people that need to meet, and there needs to be an agenda to go through, so once you've completed that agenda, stop and go back to work. What does your department director do? The directors are responsible for understanding the requirements in their particular directorate. They need to integrate those requirements and those items we just did on the page previous, the schedules and so forth, with the other department heads and with the Vice President of Engineering and the Vice President of Marketing. Provide products. You need to have a design in your PowerPoint file. I used to say charts often. It's very important to put your ideas down in a file format that the marketing department can integrate and make a cogent story out of. I mentioned you negotiate with other departments. You negotiate differences with other departments. So you're going to find those that maybe structures hasn't provided operations enough space to do what they need, so they need to get together and figure out how to fix that. As mentioned before, make sure everybody has something to do when they're working on it. And keep an updated task list. So as you scratch things off, assign something new. We kind of call that a punch list. How will you work with management? So this is, the last chart was talking to the directors. This is talking to the engineers. The managers need your help for you to contribute to the overall product. It goes back to completing the assignments that you're given and negotiating the breadth and scope of those assignments. Advise management if something looks wrong. This is real important. Automation may have a need for a round peg, and structures has given them a square hole. So sometimes that works, but it's not always. So we need to make sure that if you got something that's wrong, that you fix it. Get your stuff done on time. So if you've been asked to do something in an hour, get it done in an hour. Don't make it 2. Seen the next one before, communicate with other departments. Management can help you. They can ask you, do you need information? So you may be working on a part of a requirement and you don't know something. Tell your manager, I don't know this piece of information. Can you help me get it? Are you having disagreements with other departments? We kind of went over that. You can work with your manager and the other department's managers to overcome disagreements or come to a consensus on how to proceed forward. Are you having difficulty meeting the schedule? It could be that the task that you were given, you're working your tail off and you haven't stopped and you're just not done, so you need more time. So that's something you need to talk to your manager about. Okay, how do you relate to other departments? I think we talked about this, and you can see a repetitive theme here. Communicate. Information's got to pass back and forth. There's a table in your program book that talks about what departments need information from other departments. I would suggest that directors look at that with the engineering vice president and ensure that somebody is paying attention to that. If you have a systems engineer, that's his playground or her playground. Some of the designs require multiple departments to implement. So you need to make sure that the overlaps between the other departments are identified and worked. As we mentioned, all departments relate to all other departments. This is true in requirements, data, design decisions, collaboration on multiple design elements. There's a lot of things here that need to be discussed between departments. Your department owes a thing to every other department, and it's the same list. So we call that a give or taker list. So make sure you know what you need from other departments and you know what other departments need from you. Okay, structural engineering. You're going to see the same thing. The first thing that you're going to see in every department is it's driven by requirements. So structural engineering, how can operational efficiency be improved? Safety considerations, redundant systems, provisions for emergencies, natural hazards. Upon improvements, reduced need for human involvement. So these are topics that are important to structures, and again, they're integrated topics. Okay, so structures concerned with redundancy, and so is operations, and so is automation. Doors and airlocks, roads. The roads are in electrical. The roads are really operations. So the structures have to build them, but the operations get to lay out where they go. Electrical generation, communications antenna, port. So these are the big ticket items. This is the overall architecture of the settlement, where the big picture pieces go. Okay, so redundancies. You got two domes, airlocks, get in and out. You've got roads, solar panel, a communications antenna, and a port. So this is a very rudimentary graphic that reiterates what was on the page before. What materials do we select for the structure? So you can read that list there, and there's a bullet point, if not two, in the RFP that asks for a list of materials and where you get them. So I'll just stop and make the point. If you have a lot of stuff coming from Earth, that's not good. It costs a lot of money to get things from Earth. There are many things out there in the solar system and many infrastructure in the solar system that provides things from moon sources, from asteroid sources, from comet sources, from Mars sources. So there's a lot of places to get stuff in the inner solar system that you don't need to go to Earth for. Okay, so you need to worry about strength. You don't have to do strength equations. You can neutralize those. You got to keep the air in where the air belongs. You got to keep the radiation out from getting in, and protections from local environments. So local environments might be temperature, hot and colds. They might be excessive CO2. They might be a puncture in the pressurized hull that needs to get replaced. I think the last four bullets there we talked about already. All right, super adobe. This is more applicable to a surface settlement. The ones that we're doing, I wouldn't expect to see super adobe. I would expect to see secondary structures and intermediate structures made out of materials that are available from the other facilities that are already implemented in the inner solar system infrastructure. But this is kind of how super adobe is made. You got a bag and you fill it with dirt, sand, and you put barbed wire between them, and you can build up structures. And this has actually been done. Anita met this guy, and they're a very efficient way of making a structure on the moon or on Mars, or even out in Arizona. Radiation, again, this picture is kind of tuned for surface settlement, but the ideas are the same. If you can bounce light off mirrors, you can protect with radiation or from radiation. A couple of inches of water is just fine. So if you have water in your hull, you can take care of radiation that way. There was a gentleman, Robert Bigelow, that was going to build a space station. He's since gone out of business, but he was in Las Vegas, and I got to go to see his facility. And his orbiting, flexible, inflatable facilities had 2 inches of water in the structure to maintain radiation. So you don't need a lot. There's a lot of simple ways to handle radiation. Okay, the interior configuration. Again, we mentioned that you're going to need to get structures is going to need inputs from all the other departments on how much floor space do you need, and the structure is going to figure out how to build that or how to architect it. You need residential, commercial, agriculture, manufacturing, industrial, port, commerce, other. All of those features are in this RFP. Some of them might be addressed by subcontractors. What factors determine relative locations? Well, convenience and proximity. You probably don't want to put the store 4 miles away from the houses. You probably don't want to put the sewage treatment plant right next to the restaurants. So, apply some common sense into how the different areas are arranged and interact with one another. Some of the objectable characteristics, noise, odors, hazards, those are all things that have to be considered. So if you're worried about noise, go to human. If you're worried about odors, go to human. If you're worried about hazards, go to ops. So there's a lot of different departments that can help you understand what objectionable characteristics you might want to have to address. Construction sequence. This is something that's in every RFP. We like to see how you plan to build this thing. What comes first, what comes second? You prefabricate or you ship to site or do you construct on site? I would expect a combination of both those. Okay, how do you put this thing together? The RFPs have been leaning a lot more towards automation and jigs, and both of those things under the control of operators. So you wouldn't see, we would not expect to see a lot of things that people are doing. We would probably like to see a lot of things that machines and automation are doing that are controlled by people. Cargo vehicles, everything's got to show up in a cask. So your assembly location has to take things out of cask and erector set it together. Who knows what an erector set is? Oh, you guys are jonesing. Somebody look it up. I had fun with it when I was a kid. So get to know the size of casks. There's a subcontractor that provides casks, and it will give you dimensions and things that you can do with it. Capabilities available. There's going to be a bullet point in the RFP about telling us or showing us when different things are available during your construction sequence. Okay, operations. You guys get to figure out where do you build a settlement, and that is a request in the RFP, is pick a location to put this thing together. And what factors are important? As mentioned before, your construction materials, access to resources, minimum energy for arriving ships. This particular settlement scenario, that last bullet doesn't really apply because you're not around orbiting a planetary or a body, planetary body. But you will have to figure out how to go from the place that you build this thing to the orbit that you're going to go into. So Rohan and I looked at that. We discussed a couple of minutes about this orbit and where would a likely place to build this thing be more efficient. And we'll talk about the orbit a little bit more when we get in the RFP. Should it be built where it is operated? Well, this RFP says don't do that. It says build it, then operate it in an alternate orbit. Those few sub-bullets you really don't have to worry about too much. What factors are important for operations? So this thing is going to be a vehicle that holds a number of thousands of people that operate it and many more thousands of people that it will be taking to and from Mars and Earth. So on those trips, the people that are traveling to Mars or traveling to Earth have to have things to do. So the other people have to operate the settlement. So there's, maintenance on the utilities. There is, making sure that people are fed, making sure that sanitary things are taken care of. Does the RFP make requests concerning location? Yes. Location for building. Understanding human needs is half the job of meeting them. That's Adlai E. Stevenson Jr. And if my history serves me correctly, I believe he ran for president and did not win back in the 60s or somewhere in there. But I could be totally wrong. Okay, so operations, you guys got to worry about electric power, how you generate it, how you get to where it needs to go. More importantly, how much. Communication systems, so you can have internal communication systems and probably several types. If you look around your room here, you got your telephone, maybe face-to-face verbal, you got FaceTime, WhatsApp. There's a lot of different ways to communicate with each other internally. And then you have the way this facility is operated. So I'm communicating with you through a different type of implementation of a communication method. You've got security and administration of this university and the hotel, for that matter, that have to communicate. They may be on walkie-talkies or something. So communications, those are internal. And then there's external. You need to be able to talk to the people on Mars and talk to the people on Earth. Those are, we would expect to see external antennas and a definition of some type of communication methodology, whether it's either a high-frequency RF or it could be X-rays or it could be lasers. Those are all in existence today. I doubt we'd see subspace communications. Don't propose something that isn't viable in that period of time. That might be viable 200 years from now, but not in 25. Okay, where do you get your water? How do you get it to people? Water is life, so is power. How do you get rid of the wastes? The greater the civilization, the more helpless man becomes when the electric power breaks down. Texas went through that back in 2 years ago with Winter Storm Uri. Our power system went down for about a week across the entire state, and there was about 200 people that died, a lot of them freezing because they didn't have heat. So it was a big, awful mess, and the folks in Texas actually went through this. So make sure your power is reliable. Interior transportation. So just like interior communications, depending on how big this thing is, and structures is going to have to tell you that, you might have golf carts, you might have bicycles, you might have a light monorail. So the vehicles and the means of transportation are going to be dictated by the size of this thing and who has to go where, and who includes the robots as well as the people. You got to get things around, bulk goods around. So you're going to be handling materials and raw materials coming from different sources. You're going to be handling finished goods coming from Mars and going to Earth. People we mentioned. Okay, transportation corridors. So ops, you got to tell structures where you're going to put the roads. And they got a couple of options there: rails, roads, footpaths, robot operations. A lot of different ways that you can implement these kinds of needs. Getting enough to eat and then getting rid of it are two of the greatest problems of life. Ed Howe. I don't know who Ed was, but he's very prolific. I'm sure everybody in this room understands this point. So make sure your settlements have a source of nutrition and water and means for recycling all that stuff. It is inevitable. Okay, so farm does not equal food. You got to fill in the blanks with the process flow. So you got grain, and it goes through a number of steps, and it becomes bread. And if you got a chicken, it goes through a number of steps and becomes lunch. So we're looking for the process diagram of how you go from the raw, either vegetable items or raw protein items, and how they turn into delicious cuisine that people love to eat and where they get it. Okay, consider operations, engineering, consumer goods, products, and distribution. What will human engineering request? And there may be other charts on this one for the other departments. So they want paper and office things, clothes, shoes, food service, kitchen supplies, toiletries, tools, adhesives, paints, light bulbs. So you can come up with a brainstorming list of what people need, and or a human could, or you could ask human, what are the things that your people need that we need to facilitate logistically? Because you've got the logistics issue. Operations has a logistics attribute to the settlement as well. You're planning how it's operating. So you got to show us how you get stuff coming in a docking port to where it's ultimately utilized. Human engineering. A lot of folks, I think, discount this particular discipline, and this is probably one of the most important disciplines that I see in my work realm. We are very cognizant about how the astronauts interact with spacecrafts or space station. I've got a book about this thick on requirements to meet that. So it's an important discipline. So, okay, the rule of fours. You can live 4 minutes without air, excuse me, 4 hours without thermal control. Obvious example of this is hypothermia. If somebody goes into water in the North Atlantic, they're not going to be alive for very long. You can be 4 days without water, and you can be 4 weeks without food. So you can plan your logistics accordingly to make sure that these fours are not violated. And matter of fact, if I had to go 4 weeks with no food, 4 days without water, 4 hours being cold, and not be able to breathe, I would not be a happy camper. I would expect somebody to do something. So keep those in mind. Utilities and infrastructure. So you got to ask operations, what about your atmospheric characteristics? And the RFP is going to have a constraint on that. Okay, ops, where do you get your water and sanitary? You know, don't put the restaurant on one side, the houses in the middle, and the bathroom on the other side. That's the longest distance that someone would have to go to get food and do their stuff. So work with operations to make sure that there's a human efficiency associated with the different functions that the ops will define. Variety and quantity of foods. The food selections is always interesting to see. So we'll see what comes out. Basic commodities, I'll let you guys read this list. Communication services, transportation services. So ops is going to define these. If they put a communication service internal where you've got a push button talk panel and it's up 6 feet on a wall, anybody that's short won't use it. So, you know, look at the operations methods for internal and external communications to make sure that they've got an appropriate, efficient human interface. Community design. Edka, where are you? Okay. She's waving her hand. We have a community design expert in our midst, and she's a CEO, so some of y'all are going to have a push on this one. So, okay, how much area or volume do you need? We've got schools, medical facilities, food, where you get it, where you get rid of it, public housing areas, homes, others. Let's go back to medical facilities. At Southwest, we had some information given to the students on how many and different types of medical personnel were needed for 100 persons. So we've seen a lot of hospitals that were overkill. You know, we had a 3,000 person population and we had 1,500 hospital beds. That's not realistic. You may have a 20 or 30,000 person settlement on the moon and you've got one urgent care clinic with 3 beds and a doctor that comes in 3 times a week. No, that's probably not right either. So you're going to have to balance your medical facilities to the population you have and realistic medical services that would be needed by that population. We talked about facilities near or far apart. Okay, this next one is probably the toughest one. What makes a community aesthetically pleasing? Architectural interests, parks, remote from farming. I don't know if you were from Iowa, you would understand that. Other factors. So you're going to have to be creative in the human factors department to come up with amenities and attributes of the facilities or the settlement that are pleasing. You know, when you first arrive, you want to be embraced by some entry location that isn't stark and foreboding. You want to be open and see the shops that you might have or the entertainment areas that you might come to. So you got to think about what's going to be aesthetically pleasing and modern and comfortable. Those are all very vague terms. What kind of community is appropriate? Okay, we got urban, village, suburban. When you get your RFP, you're going to get to pick what you think the appropriate distribution of type of community. You might have a mixture of this. And then you got to work with structures and operations to make sure that what they're doing is compatible with it. Okay, so this is some criteria on home designs. So confining versus comfortable. You know, you might give a 200 square foot area for a transient to stay in, and they're going to be doing that for 146 days or thereabouts. So you want to have the appropriate type of amenities and housing or apartments or hoteling for people that are coming. And again, it's a balance between, it's the Goldilocks. You know, it's not too hot, it's not too big, it's not too small. Construction costs. So you got multi-use rooms, multiple rooms, radiation exposure. This is more, again, attuned to a settlement on Mars, whether you have no view or whether you have external view. In any case, you really don't want to expose people to direct radiation environment. You want to either shield them from it or, well, you want to shield it from it because it's going to be there. Psychological factors. I got a story about this one, but I'm not going to tell it because we don't have time. Natural light. You need to have natural light. You got to have a feeling of openness, long interior lines of sight, how Earth-like it should be. There's another attribute, and you guys are going to have to remember this because it's not in the press release or the program book or the RFP, but you don't want sharp turns on a rotating settlement, and the reason is you've got a Coriolis effect. So if I have to turn a corner very sharply, I'm going to tip over because of the way I'm in a rotating facility. So if you want to change direction, it's usually 120, 150 degree change rather than a 90. So keep that in mind. If we see, you remember this, if we see pathways that are responsive to the fact that people can't make sharp turns in an orbiting settlement, we'll give you a point for that. Okay, we got recreation. How do you go outside? I'm not sure we've got requirements for entertainment outside, but when you get the RFP, you can find out. Good food, social factors, community, fun things to do, others. Okay, I'm going to try to speed this up. Okay, we got safety considerations. So there's ways that you can prevent accidents, injuries, prevent long-term illnesses. One of the things they said at Southwest is if you go to the doctor with an illness, it's already too late. You actually prevent illnesses by having proper nutrition, proper exercise, take care of your sanitation and things like that. So the things that you do before you get ill are much more impactful to being well than the ones that you do after you get sick. Psychological factors, those are true as well. A lot of stuff out on the internet on these types of things. A lot of this information's in your program book too. So, how can resources requirements be reduced? Less or multi-use furniture. Develop cuisines not required utensils. Excuse me. That would translate into hot dogs, by the way. Use materials less changed from the natural state. Don't do that. Automation. Okay, what are your robots going to be used for? Well, the RFP's got a whole dissertation on things that you can do with automation. So they're going to include construction, maintenance functions, taking care of mundane jobs, support your business, agricultural, household uses. So automation is going to be having a variety of automation functions that are required by the RFP. Okay, you're going to have to add or tell us the numbers and types and sizes of robots. Robots might be applicable to multiple applications. The ones that help build a facility might turn into a maintenance. How do you monitor it? These are old ways to do it, but they're maybe new ways. Where do your automation, your robots go? Do they take separate paths? Do they take the same paths as the people? Where do they go when they need maintenance? You're going to have to worry about networking. You're going to have to worry about information flows, how people access it, security of that information. How do you prevent unauthorized access, blocking and hacking, system overload? This also applies to communications with Mars and Earth, so there'll be an automated network and communication attribute to those functions as well. Mainframes, personal computers, Macs, hybrids, wearables. This list is a little bit outdated. I mean, you can look at what we have today, and it's beyond this list, and we're going to be looking for imaginative things that you're going to have in 25 years. Computers and networks, numbered types. You have things that are unique to any particular application. What are your human inputs? What are your facility requirements? Your operating system software requirements? Where are the computers and robots located? I think we talked most about this. Okay, there's other things that you're going to have to ask other departments that we talked about. So this is kind of the way the departments all kind of work together. So this is what your overall architecture looks like, and that's brought to you by the structural department. Then you have the functionalities and the utilities, roadways, power, how they're located or how they're integrated into what the structures people provided from their architecture. Then you've got the human, so here's all your human interfaces that you got to deal with and all the human things that they do in and day out. And then you've got automation that kind of provides an underpinning network for all those things that the other departments have designed and implemented. Then you got your business that lays on top of what the human does. And this is a model for any city on the planet. The RFP, okay, we're a little behind schedule, but let's see how fast we can go. So, yeah. So, Rohan and I went through the RFP just a little while ago, and we came up with checkpoints or check items. We came up with a checklist of things that we're going to be looking for. So I'm going to go through what that is. I'll let you read the whole RFP when you get it. Okay. Does he go on? Okay, I'm going to talk about the orbit a little bit first. Now, it's a very interesting orbit. It was proposed by Buzz Aldrin on his PhD thesis, and it's Abhishek and Rohan and I were looking at it in Wikipedia, and it's kind of a complicated orbit to really see what it does. But by and large, it goes by Earth and it goes by Mars. We weren't quite certain if it goes by Mars once or twice, but it doesn't matter because what you have to provide is the interface when the settlement comes flying by. So don't worry about the orbit. Don't worry about how many times it goes by any particular planet or Earth or Mars. Worry about what happens when it does come by and how you get stuff up and down. There is an attribute that says you have to have an ability to maneuver the settlement in order to accommodate the next round of the cycle of the orbit. So there's some requirements further down that talk about that. Okay, we're looking for a solar sail. Anita was a sailor, so she knew a lot about that. That's why she put it in here. So we're going to have to see a solar sail. One could say, hey, a solar cell and a solar power system might go together. But right now we're looking for a solar cell, and like I said, there's requirements on that in the RFP here. Okay, so we're going to have 3,500 full-time residents and an additional temporary population of 5,500 in transit between Earth and Mars. So keep those numbers in mind. We're going to be looking for them, 3,500, 5,500. Natural views. There's two places that this comes up, so we're going to be really interested in how you show your travelers natural views of either Earth, Mars, or anything in between. We want to see something that shows us all the volumes and their uses. There will be an artificial gravity of 0.45 Gs in the living areas. So you got to define what a living area is and what a living area is not. We need to see entry and exit locations. So if you've got a docking system, that's an entry or an exit system. If you got people coming and cargo coming or going, we got to see how that happens. There may be an entry and exit system to go on the outside of the settlement to do one thing or another. Okay, next thing is protection from solar and cosmic radiation and penetrations from natural or human-caused debris. So, again, 2 inches of water will do your radiation. There's other ways to do that. Debris penetration is a little more tricky. Now, when you get near Earth, you're going to have a lot more man-made debris than if you're on Mars. But you do have micrometeoroids that are flying all around the solar system. They're little teeny-bitty asteroids that will travel at 60,000 miles an hour and put a hole in you. I'll let you take 2.2.
So you have to show us what the down surfaces are. We have highlighted some of the stuff, but that doesn't mean the non-highlighted stuff is not important. You'll have to show us drawings and allocations of where you've put your residential, commercial, community services. You will have to show us vertical clearances in each of these areas and volumes. You will also show us the process that is required to construct this settlement, the sequence in which it will be done, the capabilities that it will have at any given stage, and then in future stages. And it's important that you show us where the avenues for future expansion are available on your settlement. Please pay attention to the minimum requirements there. It's important that you show us 8 intermediary steps of building it up. Interesting one here, thanks to Anita, you have to show us a settlement design with a deployable, stowable solar cell, which is 1.75 times the area of the circle of radius of your largest rotating volume. So you have to prove to us that the sail is actually that big. The depictions must come in the pictures and designs and drawings. You have to show us the attach and the trim control systems. Also provide an interface which is about 5 meters or 16 feet in diameter, where you will have space tugs to actually boost the settlement with force. So if you look at where this thing is going around, so if you look at videos that come up on YouTube, you will see that there is a need for you to boost the settlement in a different to move it into a different direction, and you will use space tugs to do that. So you need to show us the tethers to the space tugs which match that requirement. Want to do operations, Jack?
Yeah, just to also add to that, there's the word A here, and strictly speaking, that's 1. And the red herring in this particular requirement is going off and designing what the tugs look like. So we don't want that. Space tugs are done by somebody else, and they will put on a 1/10 G acceleration on your 5-meter radius, or 5-meter diameter round surface. So this was Anita's, one of her pitfalls she'd put in there. She'd put this in there, and students would go off and just design the heck out of this, and all they need is a round disc stuck somewhere. It'll take 1/10 of a G. So be cautious of that one.
Just want to draw your attention to one more thing. In your designs, when you're showing us, we want to see both the deployed and the stowed away version of your solar sails.
Yeah, that's right here. So you got to show us how you reel them in. Okay, operations. Orbital location for construction. And Rohan and I talked about what we think the right answer would be. There could be more than one, but the key point here is that you have to justify why you're picking what you're picking. And like I said, that we have one that we think is optimum. We'll see if you guys come up with the same answer. As mentioned, the reason why you select it, and the method for accelerating the settlement from the construction location to the cycler orbit. To me, this word here, method, is a very open-ended. There may be a number of different ways to do it. I'm not sure I know what the right answer is. So we'll see what you guys come up with. And just assume that whatever you do is sufficient to provide a delta V. I'm not going to do the math, okay? So you don't have to either. Just come up with some viable concept that says this will provide sufficient acceleration to get this thing going in orbit. If we were really doing this for real, that's not a trivial solution. It's not a trivial thing to figure out.
So I also want to draw attention to, please use more standard units. If you make us do math while we're doing judging, Jack and I can come up with some really funny numbers when we're doing conversions. So if we get our conversion wrong, you lose points. So please make sure that the units that you use are standard units and most used ones.
Yeah, typical units. PSI instead of millimeters of mercury. Okay, sources of materials, this shows up twice. So we want to know where you're getting your stuff from and how you're getting it to the construction site. This means in transportation. Okay, so elements of basic infrastructure. So that term represents all of these sub-bullets here. So that's one particular checkpoint we have. So when we go to that one, we're going to look for these sub-bullets. This is green because it's not on our checklist, but it's something we might be looking for. This says it's preferred that air and water and commodities and standard infrastructure components be supplied by subcontractors. So this is a bonus question. If you show us how subcontractors are utilized to give all the things in the list above, you get extra credit. We want to see primary machines and jigs and equipment for employing construction. So you see construction now show up in two different places. We have an IOC, which is an intermediate operations capability. So we want to see what kind of things you have at IOC versus operational construction. So, and those two are out of order chronologically, by the way. So you're going to have some kind of startup when you're doing your construction. You're going to have some sort of operations. Then you're going to get to initial capability, and then you get to final capability later. So we want to see how machines and jigs and tools are used at these various points in the buildup of the settlement. All right, this one, 3.4 is, we talked a little bit about this when we couldn't come up with the right answer, but what this says is you got to have shuttle ships to and from the settlement in Earth and Mars that will transfer either 50 tons of cargo or 250 passengers per visit. So that implies either the same ship that can be reconfigured or two different kinds of ships. You've also got a space tug that's coming up that will help you with your orbital maneuver. So if you go, we did a quick little math. You also got to do your transfers in 8 days. So as the settlement passes either Earth or Mars, you have 8 days to move all your people and all your material and goods. So this requirement says in 8 days, I got to move 250 passengers per visit in one ship. And when you go back and look at the number of passengers, the most is 5,500. So to get 5,500 people moved, that's 22 ships or sorties with 250 people each in 8 days. So Rohan and I have already done that math. Now, how you do the 50 tons is a little more esoteric. We're not really sure what that answer is, whether it's the same ship or a different ship. 250 persons is like...
We have one version of the answer we tried to convert how many people equal how many tons. So we have one version of the answer. We'd like to see your version of the answer.
Right, so 250 passengers is way less than 50 tons. So by definition, you've got a different vehicle. It could be the same vehicle reconfigured, a lot of different ways to do that. Okay, the docking systems must accommodate the diverse designs of vehicles. So whatever docking system you come up with, if you imagine old Star Trek television series, Deep Space Nine, they had all kinds of vehicles coming and going. So we want to see that too. We want to see diversity in docking systems. Okay.
So we'll do this.
Yeah, go ahead.
We definitely want to see natural views of space. And while the settlement passes Earth and Mars, you want to see natural views of both. Remember that the interception will last at least 8 days, so that's 8 days of good viewing. So we will want the passengers on your settlement to look at these natural views, and you should find ways for them to do that. We want them to live comfortably in modern community environments which have housing, education, commercial, retail, medical parks, recreation, because they're going to have a fairly long journey going around that Aldrin cycle. It is required that you show us public areas with long lines of sight. We want to see a retail district because there's going to be sufficient shopping there. A list of maps, a list and a map of shops. And please suggest and the attributes that you require to keep people entertained. It's going to be a long journey. Some of them are going to stay on the settlement. Some of them are going to be temporary settlers. So you'll have to show us ways that they are kept entertained. There are going to be homes for permanent and for temporary visitors. Please keep in mind what we showed you, what is comfortable for both these sectors. The breakup of the kind of settlers who are there on the settlement is given there. Married adults, 60%, single men, 21, single women, 17. The ratios are a little skewed there, but it's still okay. And you'll need to show us interior floor plans of at least 4 home designs.
Just to point out that the demographics here for the permanent population, so that's for the 3,500 people, it's implied that the 5,500 transients also have some demographics, and they would need to be accommodated as well. So I would not have a problem with applying these same demographics to both sets of populations, even though the requirements kind of worded differently. Why don't you keep going, Rohan, and I'll do automation.
So we're going to have to see ways that you safely move people in and around the segment. We want to see tethers, handholds, cages, any mechanical helpers as required for doing work within the settlement, or people or equipment moving around the settlement. We want to see procedures for assuring personal safety of everybody who's on that settlement, so protecting them from solar flares is important. Also because of the cycle that it's on. So we'd want to see that. This one is important. We want you to design and show classroom and hands-on training experiences for temporary residents who are coming on board. And we want you to suggest topics that you will actually train these folks on. What will be relevant to them on this journey or where they will get off. It's also important that you show us the number of instructors that you are designating to do these trainings. Automation design and services. You want to show us robots, drone designs, who will do all sorts of work either from a human factors perspective or from an automation or from a structures perspective. You want to show us designs and the capabilities of what they do. They could be doing repair, maintenance, storage, and of course you want to show us special transportation routes for the robots.
Yeah, and I'd like to point out that in this particular section and in follow-on sections, there's less checkpoint items. That's because our checklist was getting full. So don't believe because there's fewer checkpoint items that the other unhighlighted words are not important. We're going to be going back to the RFP and the way it's worded when we look at all the things that automation needs to do.
Please note that the judging will happen on the number of good points that you provide and the number of not so good points that you provide. So while you don't see that many highlights, we're still paying attention to what you're saying. Most important for you to also show is while the robots are doing their jobs, you want to show us how is it that humans are monitoring these systems. You want to show us jigs that actually handle these robots as well. Very important part of the settlement is your backups, your contingency plans that you show us. Make sure that you don't have single points of success or single points of failure. We mentioned that you want to show us at least 2 depictions of your settlement, one with the solar sails deployed and the other one stowed away. You will also need to show us how it's happening. So you want to develop an automated system for deploying and stowing these away, and how you're going to achieve your velocity change. And the minimum requirement that we are going to look at is what does the operation of this sail look like with at least one intermediate step between fully deployed and fully stowed away.
Yeah, let's go back to control of boost through the space tug interface. So that's an interesting requirement because it really is an interface requirement between the settlement and the tug in terms of guidance control, which is a intricate function. So we want to see how the settlement is going to interact with the space tug in order to vector or gimbal thrust locations in order to maintain attitude of the settlement as you're going through the thrust period of time. So it's kind of, we're going to let you guys be creative in terms of how you're going to tell us how you're going to do that. But we're interested in knowing what you think is necessary at that interface in order to make that function realistic. Okay, the cost and schedule is pretty straightforward. You guys can read all this yourselves. It's pretty standard. There's nothing really new in here from other proposals. Business development, so take a good look at, we have one checklist item for section 7.8. So we're going to be looking at things that are on these lists rather carefully. So make sure you look at these. Might want to look at these before you start building your architecture so you can make sure that you can accommodate them.
Especially folks that start off with human factors and structures and you look only at your department and you start work, it is advisable and it's preferred that you read business development and operational planning clearly so that what you're building from a structures operations perspective also caters to these requirements.
Okay, so a word, I just noticed this, a word about fusion-powered ships. So where fusion power for production of electricity is fairly much a no-no, there are envisioned fusion propulsion system. Basically, you got a controlled nuclear explosion behind you that will control and push you along. So that is viable, but using fusion to produce electricity is not. We have future materials processing. So look at these carefully. Make sure you address them. Operations planning. More numbers. Okay, so we want to know what the pleasant living working environment is for 1,000 full-time residents and 2,000 settlers in transit to Mars. So that is like the initial operations capability, although it's not specifically stated that way. At each subsequent near pass, add the capability to increase full-time population by 500 and in transit by 700 until you reach the operational populations listed. So this is a timeline. It shows how you build up the populations as you go through the maturation and the buildup of the settlements. Okay, just to make sure we talk about them. Valuation standards. So the first thing we're going to look at is how viable is the design. The next, how diverse are you? How much of the requirements have you actually addressed? The next one's the credibility. So it's got to be viable. Again, no fusion power, that's not viable, it's not credible. There may be some other non-credible examples that I could think of, but I know you guys want to get on with it. Are you balanced? This underpins the teamwork that we talked about earlier, and all the departments have a common vision. I've seen proposals over the last few competitions where we had 8 to 10 pages on robots and nothing on the special RFP points that we were looking for. So make sure that you're covering the breadth of the RFP because you can see how many different things we're going to be checking off to see if you've touched on or not. So balance and innovation. If you come up with something creative, you get a brownie point for that. We talked about alternate naming. 50 pages. Dimensions, consistent units. What I don't see in here that we're looking for also is citations. So if you take something off a website, put down the URL. If you're using an automated CAD system, you can write down Blender by Bobby Smith. I'm sure there's a Bobby Smith in this crowd, right? It could be 2022 Asian regional competition, and it could be a picture of something that actually is appropriate and applicable to these requirements. So as long as you can use old stuff, as long as you cite it and it's applicable to the requirement. We've also talked about the pitfalls of artificial intelligence. If you don't pay attention to what it's given you, it's probably going to put something out there that is wrong, and we'll spot it, and we'll say, oh, nanny, nanny, boo-boo, you didn't check your AI. So we're going to pin those things home as well.
Just one thing, we had a question even yesterday saying that if you pick up a partial design from AI and then you modify it, please credit the source. You say that the image or the illustration is jointly produced by AI and who else?
Do we have the bit.ly up yet? Okay, we got to get on ours. Okay, Okay, I would ordinarily offer opportunity for questions, but we are just over time, and I know you guys want to get ready. So if you have questions, you can post them to bit.ly. Where are you and I going to hang out?
We could just be here for a while now. Yeah.
Okay, so Rohan and I will be here today. If you have questions, you can come ask us. And I think we're ready to let you go. And Abhishek, I'll give you the final word.
I think if there's a crowd to ask us questions, you can also use the bit.ly link to submit your questions. We'll make sure they are answered as soon as we can take a look at them.
Yeah, so my recommendation is, this is an exercise that we do every year. We gave you a Google form to ask questions. Make use of that, because...
Hey, we're not dismissed yet. Please go ahead and sit down. And let's pay attention. If you're talking, you're doing it wrong. Thank you.
Yeah, so just make use of the Google form that we've given you, and then at least one of the technical volunteers will reply to it almost immediately. So just keep posting your questions. Most of us will be either hanging out in the auditorium or at the cafeteria on the first floor. So if you want to find one of us to ask questions, that's totally fine. If you can't find us, then you can always find us on the Google form. So all the best. It is 2:10 right now. If the the presidents of each company, if you guys could come to the stage, we'll assign 2 of the power extension cords for you and give you a rim of paper. Thank you so much, and you are free to disperse.
Presidents? Presidents?
Guys, please be seated. We'll be allotting you your classrooms right now.